All right. So a continuation of total differentiation. In the last video, we looked at total differentiation. Talked about, yes, we also did this exercise. So we're going to continue with this now. So you're given if z is a function of u and v, z is a function of u and v, where u is a function of x and y, and v is a function of x and y too. So z is a function of two independent variables, u and v. But u now is also a function of two independent variables, x and y, same as v. Now we want to find the differentiation of z with respect to x. We're going to use partial z over partial x. Why? If you check the last video, the last video we used normal normal differentiation. Since u and v are function of just or x and y, then we are function of just a single variable t. But now u is a function of x and y, v is also a function of x and y. So everything here is going to be partial, since each of them are functions of two separate variables again. So partial z over partial x is equal to partial z over partial u times partial u over partial x plus partial z over partial v times partial v over partial x. Then partial z over partial y. You can see it now. So since the final function variables are x and y, we need to express z in terms of x and also express z in terms of y. So partial z over partial y is equal to partial z over partial u times partial u over partial y plus partial z over partial v plus partial v over partial y. Alright, so this is a formula I just need to take note of. Basically, one of the things you need to take note of. This one now is for three functions. It's the same thing, but just that you're giving phi is phi. Phi is a function of u, v, and w. U is a function of x, y, z. V is a function of x, y, z. W is a function of x, y, z. So now we need to express phi in terms of x, in terms of y, and in terms of z. So this is it. This is it for you're giving them three different independent variables. Now let's look at the question. Z is equal to ln u square plus v. U is equal to e exponential x squared plus y squared. So exponential x squared plus y squared, they are together. And then v is equal to x squared plus y. You're asked to find partial z over partial x and partial z over partial y. So now z here is a function of u and v. U is a function of x and y. V is a function of x and y. So we're going to make use of this formula. We'll make use of this formula. Solution. Z is equal to ln u squared plus v, comma u is equal to exponential x squared plus y squared. V is equal to x squared plus y. From this thing, we will need this thing. What do we need? Let's look at it again. We need partial z over partial u over partial x, partial z over partial v over partial x. Then since we have this here, we will just need partial u over partial y and partial v over partial y. So that's what we'll look for here. Partial z over partial u. You know how we differentiate for ln or logarithm is going to be 1 over u squared plus b. Okay, let me not say logarithm for ln, because logarithm, when you are differentiating, like there are other things you do for natural log, but that's not the case now. So for ln, u squared plus v is 1 over everything. Then you differentiate the inside with respect to u, so that's 2u. When you multiply, you have 2u over u squared plus v. That's the partial z over partial u. For partial u over partial x, that's this now. It's going to be it's going to be differentiate the dependent variable. The dependent variable is exponential x squared plus y. That's the dependent variable, exponential x squared plus y. Now differentiate the independent variable with respect to x is 2x. So when you multiply them, you're going to have 2x exponential x squared plus y. Then you have partial z over partial v. Partial z over partial v, okay. It's going to be 1 over u squared plus v times differential of this with respect to v is 1 is equals to 1 over u squared plus v, yes. Then partial v over partial x is going to be 2x. That's just it. So we can solve for partial z over partial x. You put in your formula, multiply them. Your final answer, is 2x plus 4u x exponential x squared plus y squared over u squared plus v. Okay, from here I collected like terms. Okay, having multiplied this, I just collected like terms, added both of them, and that's how I got that answer. I guess I could say in the most simple form. Now for partial u over partial y, this is what you get. For partial u over partial y, when you're differentiating this with respect to y, with y, yes, it's going to be 2y exponential x squared plus y squared. That's what we go here. 2y exponential x squared plus y squared. Differentiate this with respect to y is going to be 1. Partial v over partial y is 1. Partial z over partial y is equal to partial z over partial u times partial u over partial y plus partial z over partial v times partial v over partial y. Now partial z over partial y is equal to, okay, this is the formula, so you just put in the values for each of these, you multiply it. At the end of the day, I also collected like terms, and this is the answer I got.